morning, integrated topics students. Today, you're going to need a pencil, a ruler, calculator, your homework ready for collection. So the homework was the 7 problems, of which 6 of them were graphs. The last one dealt with a word problem situation that you had also graph. And then we have the white packet entitled Systems of Linear Inequalities. It starts out with Jack is going on a hiking trip. So once all that has been collected, first part is some notes. So you definitely want to write this stuff down. So we're going to go into graphing systems of inequalities. So last time we dealt with just inequalities, just one at a time. Now we're actually going to deal with the whole entire system. So for a system to solve it, you will need to find the order pairs that satisfy all the inequalities involved. So now, if you recall, when we did systems of equations, a system is basically like 2 or more, in our case, inequalities that we need to find an order pair or multiple order pairs that will basically make both of those inequalities true, which we're going to see a couple examples. So instead of just looking at the point of intersection, just like system of equations, we're actually going to look at the solution set as is represented by the intersection and the overlap of the graphs. So this is why we're going to do system of inequalities, because we're doing the shading and we're going to see where those shading portions overlap. So we have a total of 3 examples. So the first example is y is less than negative x plus 1. Y is less than or equal to 2x plus 3. And first things first, when you look at your inequalities, you need to ask yourself, is it in that slope-intercept form? So slope-intercept form, to refresh your memory, is y equals mx plus b. The only difference between what we're dealing with is instead of an equal sign, you're going to have inequality symbols. Okay? So first things first, you should ask yourself, is this in slope-intercept form? In this case, both of our inequalities are in slope-intercept form. So now we can just go right ahead and graph it. So one of the things I keep seeing, a lot of people don't know where to start for the graphs. So for this first inequality, you always want to start with the number and the symbol. Something that does not have to deal with y and does not involve x. So that is called your Y-intercept. So this is where you're actually going to put your first point on your graph. So since we have plus 1, that's telling me I should have a point on 1 on my y-axis. And from that point, I'm going to look at my slope to tell me where to go in order to draw my second point. So my slope, if you remember, it's rise over run. So in this case, I have a minus, and there's always assumed that there's a 1 there. So I would have a negative 1 over 1. Anytime you see a whole number, that number is over 1. So that's telling me from my y-intercept, I need to travel down 1 and over in the positive direction, which is the right 1. So I need to go down 1 and to the right 1. Okay? So that's very similar to what we've been doing, especially with any kind of linear equation. But now, since we're dealing with the inequality, we need to figure out what type of line we need to look at. And how I can tell that is by my inequality. So my inequality is less than. It's not less than or equal to. So if you refresh your memory when we're doing the graphing of just one of these, when I got a less than, I should be creating a dashed line. And the reason why it's dashed, we're not involving those points that are on that line. So now, I'm also got to figure out which way I'm going to shade. Since it's less than, that means I should be shading the bottom portion of my graph. So this is telling me all the points that are within that shaded area, all those points are a true statement for that first inequality. So now, since we have a system of inequalities, we need to look at the second inequality, that y is less than or equal to 2x plus 3. So again, I'm going to start at the number at the end, which is a positive 3. So that means I should be putting my first point on positive 3. From there, I'm looking at my slope. In this case, it's a 2. So that means I have 2 over 1. So my rise is 2, and my run is 1. So I'm going up 2 and over 1 to make my next point. I'm traveling up 2 and over 1. Okay, so I got my points there. Now I need to look at my inequality. Okay, it's less than and equal to. When it's equal to, that means I'm drawing a solid line. And since it's less than, I'm going to shade the bottom. So that means all the points below that line, even though most of them are positive, will satisfy this bottom equation. So just like when we did system of equations, we wanted to find now what point do they have in common. In this case, we want to find out what points do they have in common. Where does my shading overlap? So just looking at my graphs, it looks like most of my shading is overlapping right in this section here. So if you notice, right in this area, I have everything is overlapping. Okay? So that's telling me any point that I pick within that highlighted area is going to satisfy both of these inequalities. So let's test it. So if I pick 0, 0, that's in that shaded area. That means if I plug a 0 in for y and a 0 in for x, I should get a true statement each and every time. So that first inequality, I'm going to have 0 is less than 1. Okay? In the second inequality, I'm going to have 0 is less than or equal to 3. Remember, right here, that's 2 times 0. Anything times 0 is 0. Plus 3 will give me 3. So 0 is less than 1. Is that a true statement? Yes, it is. Is 0 less than or equal to 3? That's a true statement as well. So as long as you can come up with a true statement for both inequalities, that means that all these points in this shaded area is going to be true. Now, if you don't believe me, let's use another point. So let's see. Okay, we don't want to erase today. Okay, whatever. Um, let's pick -2, -2. So I'm going to use -2, -2. So here's -2, there's -2, right there. So that means where I see a y, I'm going to put a -2. Where I see an x, I'm going to put a -2. So I have, for the first one, -2 is less than a negative times a -2. Because remember that -2 is only going in for the x. So negative times a -2 gives me a +2 plus 1. So now I have -2 is less than 2 plus 1, which is 3. So is -2 less than 3? Think of the number line. In order to prove that it is true, yes or no, think of your number line. So -2 is right here. +3 is right there. Is -2 less than -3? Yes, it is. So that is a true statement. So now, let's do it for this one. You have -2 is less than or equal to 2 times -2 plus 3. So 2 times -2 is a -4. -4 plus 3 gives me a -1. So is -2 less than or equal to -1? If you remember that number line, here's 0, here's -1, here's -2. Is -2 less than -1? Yes, it is. So we have a true statement when we plugged in the same order pairs and for x and y. So that means any point within that shaded region is going to be a true statement for our inequality, our system. Let's try another one. So first things first, are we in slope-intercept form? No, we're not. So we need to convert that into slope-intercept form, meaning we have x minus y is less than -1. We need to solve for y. So we're going to subtract x on both sides. You have -y is less than -1 minus x. Instead, I don't want just y, -y, I want just y. So that means I have y is greater than, because I divide it by a negative, is greater than 1 plus 1x. So my y-intercept in this case is 1. From that point, I'm looking at my slope, which is understood as 1 over 1. That means I go up 1 and over 1. Up 1 and over 1. I'm looking at my inequality. It's just greater than, so that means I'm doing a dashed line. And since we flipped the sign to make it greater than, that means I'm shading the top. Okay, so that's all for that one. So now I need to solve the bottom one exactly the same way. Okay, gonna give myself some room here. So I have x minus y is greater than 3, subtracting x on both sides. So I have -y is greater than 3 minus x. Divide everything by -1 because I want just my y. That's causing me to flip my sign. Okay. So then I'm starting at -3. Then I go up 1, over 1, up 1, over 1. Drawing again a dashed line. And since I had to flip that sign, it's less than, so I'm shading the bottom. What do you notice? Do they overlap? Hopefully you say no. So if they don't overlap, what's my solution? Right now, I have what's called a no solution. Not because they're parallel lines, it's no solution because they do not overlap. Okay, so what we did was we finished the packet after we did some practice. They did not have homework, so they can enjoy that. And if there's any more, we're going to do some more of this for the next class. All right? So I will talk with you guys later.